everyone, I'm Istvan Szoboszlai and I will be talking about how we use Elasticsearch and mainly Kibana for visualizing GPS data, GPS logs and GPS trips. I have a Hungarian company called inepex and I live in Zurich and I founded the company there too. That's GPS, two logos. Yeah. So, a little overview of what I'll be talking about today. First, I would like to set the context. What is GPS tracking? What is it used for? Then a little bit about the data, because that's what we are interested in most. And then what the stack that we use. So what stack is Elasticsearch part of? In our solution, and then some details, some interesting details about the solutions that we provide with Elasticsearch and Kibana. So, as the first question, who needs GPS tracking? Actually, I think every company where they have a moving workforce, because the first purpose is actually just to see, because if you have people who are working all over country, then you don't know what they're doing. So GPS tracking is a really easy solution for that, to just actually to see what's happening, and then based on measurement data, then you can decide based on data. And the second purpose, when you already see, then you can optimize, and it's the best use cases actually are where you have some kind of a plan for like your people are doing different tasks, and then you really have to plan it. It's not just like there are 2 people who you say, okay, go there, but you have 50 people, then you really have to have a plan. And then you do the plan, you measure, and then based on the difference, then you can optimize. So what's the goal that we use these tools for? It's actually like we want to convert the GPS log data and the context of the company that the GPS data come in to insights for the company. And we have found that the drill down analytics, what Kibana can provide, is a really good tool for that, to gain insights. And the more advanced goal that we can have is where we also have the plans, and then the measurement, and then we can compare. So actually the flow goes, we have the points, and then we have some kind of a GPS tracking app, and that's for one vehicle, one person, and then the big picture is then shown in Kibana dashboards. And when we are talking about GPS tracking, the question always comes up if it's a good or evil thing. People tend to think about GPS tracking in context of like it's some big brother thing that I'm always tracked. But I think if we really, so it depends on the context. It's like a knife. You can also kill with a knife, and you can also like just prepare your dinner. And so the purpose is the most important thing. And in our view, actually, this is a tool that enables the people in a company to be a more efficient part of their team, to enable better communication and optimization. And actually, of course, privacy should be respected. Okay, so about the data, so where do we have the data from? There are 2 solutions to collect GPS data. One is like there are all of these kind of devices, GPS tracker, that you can install in a vehicle. You install it, and then you have a reliable source of location data for a vehicle. Or actually, you can have a software that you install on the phone. We have a Android-based software, and that turns your phone into a GPS tracker, and the irony here is that actually I think the phone solution is more like respectful for the privacy, because it's really easy to just turn on and off, and you have a lot of like capabilities of also of your phone that make sure that the software doesn't get GPS data. And so the type of the data is like the general, like what an NMEA sentence like that comes from the GPS module itself, like coordinates, time, speed, having like some kind of accuracy data. And like with built-in GPS trackers, there are multiple inputs, analog, digital inputs, and there can also be like data from the board computer of the vehicles. And on the phone, there can be anything that like battery. There can also be some kind of inputs from the users, and of course debug data that we use to make sure that the data that we gather is reliable. Just a little bit about so our scale. It's not like huge, but maybe most presentations here about like hundreds of terabytes of data. So in our case, like a few tens of thousands of devices, like just hundreds of megabytes in SQL. The trips are like 50 million trips roughly, 60 gigabytes data, coordinates like 10 billion in this order of magnitude, like a terabyte. And we also have like high resolution coordinates for like debugging purposes and some machine learning data, and that's also roughly a terabyte compressed that we only load to our Elasticsearch clusters on demand. And then we don't really use the cloud. We use bare metal, self-hosted services, mostly open source stuff. Like these are order magnitudes are like hundreds of cores, terabytes of data, tens of terabytes of disks. But only from that, only like a little. So for the Elastic clusters, we use only a fraction of that. So our goal is to visualize the data in Elasticsearch, and for that, we need to specify the data units. Two main types of data units. One is like the raw log. Let's say the raw log, so each coordinate that we collect, and the other type is the trips. The trip is just like from A to B. Someone is like driving or getting some from A to B, and then in B does something. So in our case, that's the basic unit. But it's also so the purpose of the trip is to be somewhere and do something at that point. And both of these types will be analyzed in the context of the company. So of course, in Elasticsearch, you have to denormalize your data if you want to provide visualizations and dashboards, and enhance them. And the context is always like the state of the company in that point in time when the log arrived. And like how we enhance the data is like we can add addresses, point of interests, resources of the company. We do that also with each point in time or each location. And for the trips, there's a little bit more rich data. We add some statistical data to it, like drive time, wait time, kilometers, and also we always calculate the optimal version of each route, so that we have also we can also analyze how optimal the trips were, and we also store the plans if there are any plans in the same index with the trips, because the plans are planned trips and then there are measured trips, so that we can also analyze them on the same visualizations. So just a little story how we got to use Elasticsearch. It was like we had, actually in the beginning when we had this whole GPS tracking product running, then we won a bigger tender for a company with more than 3,000 agents. And we implemented their needs, and we wanted to create some kind of a analytics solution. And then we just found out that already with this relatively bigger scale, but SQL queries were just not cutting it. It was too slow for like tens of millions of trips. And we built an ETL pipeline with Elasticsearch and Kibana in the sync in the end. What the client could see, and they really loved it because like when you show your visualizations and then they have some question, okay, and could we also look at that, and that you can just do it right there because it's so fast that the result is just there. They really fell in love with the solution, and they use it since then. And so that is why actually our second approach was to just build a new system around this idea that actually what these companies need is that they want to understand their data in their context. And for that, this kind of drill down analytics and self-service analytics is a really efficient tool. You don't have to, so what you can provide with Kibana with some dashboards, it takes months to implement it with some kind of custom programming. So why Elastic is a little bit of like there was some luck with it. So I wouldn't say we are a small company. I wouldn't say that we did a really comprehensive analysis of what would be the best tool for this. We did look at some solutions, but we prefer open source. Actually, at that time, still like it was like 16, I think Kibana or Elasticsearch was fully open source. It's still open source enough for us. So that's one point. This all-in-one solution with Kibana, and so database and Kibana frontend was I think a really good thing. It's also, of course, quite well optimized for geo and time series data. So actually, GPS logs are just logs as like any log from servers. Just have some geo properties, and it's really fast. Like for us, it was really fast. Yeah, actually, Kibana itself is again it was one of the biggest pros inside of Elastic. And these runtime fields are actually also really good because so at first we started with these ETL pipelines. We ran them every day or so, and then to modify it and then rerun it for like years, that takes time. And to just try out some new things, it's really easy to implement something in runtime field. Although I would say that the person who gave the painless name to the scripting had a sense of humor. So that's where we have most of, yeah, it works, but like until it works, sometimes it takes a little bit of effort. Yeah, of course, these kind of statistical capabilities of Kibana is so this is really relevant. I wouldn't say we use that to full extent, but like basic bucket segregations and these kind of things are really powerful. And I would also say that the mapping capabilities, so just how you can put your document on the maps and implement like interactive and quite sophisticated solutions. I don't know anything in the industry that is as capable as the maps in Kibana. Yeah, a little bit like geo stuff. So like it also was like we have heard that Uber uses it for geo stuff. Then they would say, we thought that then it will be good enough for us too. Yeah, Lucene is already like built on quite strong geo thing, shapes like GeoJSON. There are really good geoquery derivations, heat maps. You can also have your own vector ties rendered, and yeah, also like Kibana uses the open source version of yeah, so MapLibre is already a fully open source version for the mapping tool. So a little about the stack, we try to use modern technologies like only a few. Like we also mostly build an open source mapping data and other like open source tools around OpenStreetMap, and we run all our stuff in Kubernetes. We love Kotlin and which is a better Java in our opinion, and we use Micronaut instead of Spring Boot, Kafka Flink for real time like stream processing of this data, which we'll most likely replace because it's a bit too bloated. And for like the real time stuff, like the real time data propagation, gRPC, Kafka, and OSRM. OSRM, if you're not familiar with that, that's a really good open source routing engine that works with OpenStreetMap data, and like just some numbers. We tested it on like between two random points in Hungary. The average response for a route for a car routing, it was like 3 milliseconds. It's really fast. Actually, to have like we calculate all these optimal routes for all the trips and then store them in Elasticsearch. And so if that would not be an open source thing that we can self-host, it would cost so much that it wouldn't be possible. Like with like Google Maps, you pay tens of thousands of dollars easily for this kind of like a few millions of trips. So let's get into the use cases. So the first use case is what I mentioned, that there is this multinational company with 3,000 agents. There we track only phones. That's our own like software that turns your Android phone into a tracker, and it's used for mileage accounting and work time measurement. What may be interesting, they have a multi-level employee hierarchy, which we solved in a way that also in Elasticsearch, each level only sees the data that they can in the hierarchy. And actually this whole, the Kibana dashboards or visualizations are embedded into an Angular web app. So this is an Angular web app where specifically developed for this client. So what happens here is that, of course, we have the logs, and then we generate the trip visits, and then there are some roughly or quite sophisticated algorithms to determine which trip was like private and which trip was company trip, a business trip, and there are processes where like so this is, for example, an interface where the bosses of these agents can really quickly assess, okay, is it good like that, or I would like to change something, or accept something, or decline something. And then actually all of these data, these declines and acceptances are also put into Elasticsearch, so that each level can see those kind of dashboards that they really need to do. Actually, these are some kind of dashboards that they really specify. Okay, I want to show our bosses this. Or on the other, the right side, you can see some kind of like, it's called a zoning visualization on a map. And there it's like each color is for each agent, and then each agent like has all their visits bound to them with a line. That was also quite easy to implement in the mapping in Kibana. And so the use case too is that actually the next level of our stuff, where actually all these services can be provided for a lot smaller companies. So this was a multinational company with higher budget, but we have seen that this kind of GPS tracking with the purpose of showing data in dashboards in the context of the company, that is useful also for smaller companies, but it has to be prepared that they cannot afford to have some sophisticated solutions developed. So that was the trigger, and then so in the new thing we can track flows and also these kind of built-in trackers. The same purpose like mileage and work time reports, but here we also have this kind of plan, measure, compare thing. We can also like do some kind of automated planning, and we also put all the results of this kind of automated planning into Kibana, and that's actually really interesting. So we do a lot of like experimentation with the data, and then Kibana is always a really good sync for the data where you can display the data really easily. How much time? Like 10 minutes? Okay. Yeah, okay. So here the core of this use case we already like have real-time stream processing. That was the biggest like challenge. So as each log point comes in from the GPS tracker, that triggers the next step in like a stream processing pipeline, and at each step, so the first step is like enhance the coordinates. The second step is to do the trip visit, like the trip generation from the coordinates, and then to compare with the plan. And in each step, Elasticsearch is the sink where the data goes, and then from there will be reread for the next step. Yeah, and maybe one more interesting, I don't know if you're familiar with, how familiar you are with open source, like OpenStreetMap technologies. The Nominatim is a geocoder, quite well-known geocoder. And we also put to each coordinate like some address, so the address on the map, and also to the trips. And then yeah, the result is this kind of like, we also have an Angular app to show the trips, and here already like everything that we show on the map on the custom app is coming from Elastic, and we've observed that it's like really fast compared to our older solution, which was already not built on CQ, on some other database, but it enables, the aggregations enable different kind of user interface. And then the purpose here was also to integrate custom reports from Kibana into the app. About some interesting tricks or solutions that we had during implementing Kibana. Elasticsearch is like what we do is like all the context of the company is stored correctly in time, so we always know what was the context of the company when a specific GPS coordinate arrives, because we know that we will have to rerun these things when we change the logic for the enhancement or the classification of this data. So, and if like you don't know what the context of the company was back then, you cannot correctly rerun these things. That's actually quite a difficult problem. And they also have this kind of high resolution data, like so our phones can send or collect each GPS log that that each GPS point, so to the second accuracy in a compressed format, and then we can also then show this data, this 1 second resolution data on Kibana maps for debugging purposes. I think I'll go to the next slide. So one more very interesting thing what we did, I think, is that we integrated Kibana without the advanced authentication features that Kibana has, and it's seamlessly integrated into our web apps, and that's like solved with a reverse proxy that adds the authentication headers automatically. And for each company, they have some, like, we generate their own passwords that they don't see it, so it's transparent for them, and then the test password will be added to these requests. And for the for what they can see in Elasticsearch is that actually the trick is that we just add, for example, for the trips, we add like their ID of their organization to the trip, so, and then they will only have rights for that index pattern in their space. Yeah. Yeah, actually, so this is what I wanted to talk about. If you have any questions, please feel free to ask.